Hello and welcome to the fourth video in my series on VEX IQ, VEXcode IQ blocks. This video is going to be on displaying information on the screen. So perhaps not as exciting as the usual robot movement stuff that we do, but this is actually a really important skill and something that is particularly useful for debugging, because you can make sure that your program is working with the data that you believe it is working with. So let's think of an example. If your robot's driving forward and using the distance sensor to detect when you're going to collide with an object, and every time you're getting far too close to it and you're thinking, well, I've put in my code that I want to stop 20 centimeters from the object and I'm stopping when I'm much closer or I'm hitting it. What you could do is then you could print that data, so the distance that the distance sensor is actually reading, to the screen, and you can see in your program then why that's not working. It might be that you're working in the wrong unit. For example, it's 200 millimeters rather than 20 centimeters, and so therefore you're actually getting 20 millimeters away from the object, something like that. So it's a really important thing to be able to do, and really useful. So for this tutorial, all we're going to be using is a VEX IQ Brain with a controller linked to it, and also we're going to be using a gyro just for a bit of data. It's going to be, but other than that, we don't need a robot with motors on or anything. Right, let's jump to the code. For displaying data on the screen, the bits we're interested in is under the looks palette, and it's these purple commands here, so the various print commands, and I'm going to work through them, gradually building up some code so you can see what the different functions do. So let's start with the most simple one. I'm going to turn my brain on here. Okay, and I'm just going to print one line to the screen. So I'm going to grab my print command where it says print hello, and I can type something in this box. Now, brings me to the first point straight away. The maximum length of string that you can put in here, the maximum number of characters that you can display, is 21 across one line of the IQ display. So the IQ display is 21 characters wide. VEXcode IQ blocks will let you continue to type much longer strings than 21 characters, and that means they'll just go off the end of the screen. It won't wrap them. So just remember there that you've got 21 characters, and I think I'm just inside, I think I've maybe got 20 there. So that's the first thing I'm going to do. I'm just going to download that. Well, let's save it. And then we'll download that to the brain. I'm just going to put it into slot 1. And then come over here and run it. And there we go. So just simply displaying some text straight onto the screen. So that's a nice simple one. Print command displays whatever text you type into it on the screen. I'm going to just jump down to this one next, set cursor to next row. So the next thing to consider is how many rows are on the IQ display. So that's how many lines of data down you can display. So it's 21 characters across and 5 lines down that we have to work with. So if I put set cursor to next row and then get another print command, like that, put another string of text in, download it to my brain, and then let's run that one. So you can see now that on the second row of the screen is where the next line of text appears, because we set the cursor to the next row. So it always just moves down one, and we can do that 5 times before we hit the bottom, so the 5th one there. So that's the set cursor to next row. We also have set cursor to a specific row and column. So let's say if I just break that off here, move this block out of the way for the time being, and I'm going to bring this block in, and as I mentioned, we've got 5 rows. That's the maximum we've got on the IQ Brain. So let's set that one to the 5th row. So what this is saying is I'm going to it will always start at 1 1. It's probably good practice to do this just to make sure. So we're saying, well, we want to start printing at row 1 column 1, so in the top left hand corner of the brain. Then we're going to print the first string. Then we're going to move all the way down to the final row, the 5th row, still in column 1, so on the far left hand side of the screen, and then we're going to print the other line. So download that. and run it. And now you can see that the second line of text is right down at the bottom on the fifth row. Now let's come to the clear commands. So you've got clear all rows and clear row and then a numerical value. So let's start with the clear all rows. That's fairly self-explanatory. What I'm going to do is I'm going to put a little weight in there, put a little weight in there. Let's say just 3 seconds, and then I'm going to clear all rows. Now let's see what happens if I run that. So prints my text, and then after 3 seconds that clears the entire display. The clear row command, let's go back up to the looks. The clear row, we can just clear one specific row of the screen and leave all the rest of the data on there. So in this case I'm going to clear row 1 but leave row 5 on. So let's see what happens now if I do that. So I've got both lines of my data, but after 3 seconds the top one disappears and the fifth one remains because we only asked for row 1 to be deleted. So that's our clear commands. And then the final one we have here is the set precision. So precision can be 1, 0.1, 0.01, 0.001, or all digits. What this is how many decimal places the brain will display a numerical value to. So let me demonstrate that. Let's think of the best way to demonstrate that. I think what I'll do is if I get rid of some of these for now, tidy up that a bit, and we're going to have 5 different rows. So 5 different rows of data. 1, 2, 3, 4, and 5. And then what I'm going to do is on the first row I'm going to set the precision to 1. On the second row I'm going to set it to 0.1. On the third row 0.01. On the fourth row 0.001. And on the final row all digits. And then what I'll do is I will print something that I know is going to have quite a few decimal places to it. So I'm going to so this is a divide block here under the operators palette. And what I'm going to do is I'm going to divide 20 by 19. I know that will give me a fair few decimal places. So I can drop that straight inside my print command, and then I'll just print this the result of this sum straight to the screen. I'm going to duplicate that block, so I've got 5 of them. So I'm just for now going to display the same thing on the screen over and over. So after I set it to precision 1, I'm going to show that on line 1, this one on line 2, this one on line 3, and it's the same sum every time. But let's see what happens if we display that to the screen. So I'm going to download my program and then run it. And there you can see, so on the top line, well, let's start from the bottom. So on the 5th row, that's the full value that the brain has stored in it for that sum. So for 20 divided by 19, it's 1.052632. And then you can see the next line up from that, we're going down to 3 decimal places, and so it's rounded up there to 1.053, and then 1.05, 1.1 because it's rounded up. So if it was 0.01, 2, 3, or 4, it would round down, and 5, 6, 7, 8 round up. So it's rounded up to 1.1, and then we're just seeing the whole number in the first row because we're just showing it to 1 digit. So that's your set precision, which can be pretty useful because especially when you're doing mathematical functions, you don't really want to see that level of precision. You can always just set to fewer decimal places. So that covers all of the commands that we have. Now I'm just going to show you a bit of how the display actually works and how you can use it in different ways. So we've already looked at, you can print data on the first, second, third row, and also here you can choose which column to print it on. So you could start printing further along to the left of the screen. Let me just show you a little bit about, a bit more about how that works. So probably quicker if I just start this again. Let's get rid of all of these. So what I'm going to do is 5 different positions on the screen. I'm going to print some text. So let's put those on here. I'm going to start at 1, 1, and I'll print I. And then what I'm going to do is I move down. I'll put my name is Chris. I'll display on the screen. But what we'll do is we'll move the cursor along each time. Okay, so what I'm going to do is each time a word finishes, I'm going to move down to the next row on the display and then carry on from there. So this is going to be in 1 and 2. Column 1 and column 2 will be H and I. And so what I'm going to do is on the second row, I've already used 1 and 2, so I'm going to start at 3. And then I've got another 2-letter word. So on the third row, I'm going to start at 5. Then I've got 4 letters on there. So on the fourth row, I'm going to start at 5 plus 4, so 9. And then another 2 letters. I've got out of sync here, haven't I? So that's, yeah, the first one's there, and the second one's on 3. Yeah, third one. What am I doing? Yes, that's right. 5, 9. Add another 2 to that, so 11 for the last one. There we go. I was on the right track. So now if I download this to my brain and run it, so you can see what I've done there. I've printed a piece of text, the last one where it says Chris. I've left that on row 1, so I need to change this to 5. Let's run that again. And there we go. So where each word finishes, it moves down a row and starts printing the next word. Now, if we don't clear the display, you can just continue to add things even to lines that already exist. So if I just duplicate this now, so exactly the same block, but what I'm going to do is I'm going to reverse the order of the columns. So we're going to go 11 here, 9, 5. So this one will effectively just print over the top of itself. 3, and then 1. Now if I add this to the bottom, let's see what happens here. So what it did first was it came across and printed the same as we did last time, and then it came back and printed this way as well. And because we haven't cleared the display at any point, it's just continually adding that additional information to the screen. And that's going to be really useful in the next part of the demonstration, which is when we want to display data from a sensor, we can use that then to print a label and then a value for it on the same line. So let's take a look at that. What I'm going to do now is, using the devices menu, I'm going to add the controller, because I'm just going to get some data from the analog axes of the joystick. So our joystick's got some digital buttons, and it also has the analog axes, and there's 4 analog axes. So on each joystick there's up and down, that's an axis, and left and right is an axis. So I'm going to add a device, which is my controller. Don't need to configure anything here at the moment, because all I'm going to do is just read some data from it. So that's all I need to do at this stage. Let's hide that window. I'm going to do 2 things. The first pass of printing data to the screen is going to be setting up the labels. So I'm going to have 4 labels, which will be axis A, axis B, axis C, and axis D. and I want those to be on the first row, then the second row for B, third row for C, fourth row for D, like this. So that's kind of like my first pass, if you like, at printing data to the screen. The second thing I want to do is actually start displaying the joystick values. And I want to display the relevant value next to each of the labels. So I'm going to duplicate this because it's going to be very similar. And go to my sensing palette here. And the one I'm looking for is this one. And this block reads the data from the 4 analog sticks. So let's pop one of those inside each of the display commands, each of the print commands. And so it's going to be A, then B, then C, and then D. So that's the 4 axes of my joystick. And I want to print them on row 1, 2, 3, and 4, the same as the labels. But what I want to do is print on a different column so that it appears after the axes. So my axis is 1, 2, 3, 4, 5, 6, 7 characters. It's A, X, I, S, space, A, colon. So that's 7 characters. Plus also, I want to leave a space after the colon, so the data is not printed straight away, there's a space, and then we print the data. And so that would be the 8th space, would be the 8th one, and then I want to start printing again on the 9th column. So I'm going to go put 9s in all of these, and I can click those together. And the last thing I need to do, if I put this on here, it's going to be no good because we're trying to read data from the joystick, and we need to continually do that. So this entire thing needs to be inside a forever loop so that we're continually checking it. And the last thing we need to do is to clear the display. And the reason we need to do that is, so these analog joysticks, they return a value of 0 when they're in the middle. And then depending on which joystick you're using, it will return a value of up to plus 100 or 100 in fully deflected up, and minus 100 fully deflected down. So you can imagine if you don't clear the display, it's fine when it prints 0 at the start, that will be fine. If you push the joystick forward and it goes up and it starts printing up to 100, that's fine, because it's just going to be overwriting the 0. So that 1 character of 0 will be overwritten with 3 characters of 100. When you let it go back down to 0 again in the middle, if you're not clearing the display, the 0 will then be printed over the top of the 1 of 100, and the other 0, 0 will remain because we've not cleared it. So we need to make sure that at the very end we clear all the rows. And I like to, before I clear all the rows, just add a little wait in. And that can just be, you want a really short one, you don't want it to be long. I'm going to say 0.1 seconds. And what that allows is it gives time for the display, for the LCD to catch up and make sure all that data is printed before it clears it again. It's quicker for the display to clear than it is for it to print data to, and so you can get to the point where it hasn't managed to, all the LCD hasn't managed to display before you've cleared it, and then you might not see anything at all. So I always put a little wait in there. Right, let's download that to the robot. And I'm going to need to turn my joystick on because it's a joystick program. When I run it without the joystick switched on, it'll say connect controller because it is waiting for my controller to be connected. As I turn it on and it hooks up, now we're starting to run our program, and you can see there, so I've got my labels that I printed, all the various axes, and then at the moment it's showing zeros for all of the values of the data because the joystick is in the middle. So axis A is up and down on this joystick, so as I move it up, it should go to axis A goes into a positive value, up to 100 at the top, and as I move it down, it goes to a negative value to minus 100 at the bottom. Now, something that was interesting there, and this is exactly the kind of thing I'm talking about when I say it's useful to be able to see your data, actually see what your brain is receiving in terms of data. As I was moving this one up and down, you can see I'm accidentally kind of feeding in a bit of axis B, which is left and right on the same joystick. And quite often you see, if you're struggling to control the robot, it might be because you don't realize that when you think you're just pushing it straight up, you are actually feeding in a little bit of a second axis as well. And so then you can see that data. You can understand why the robot might not be driving perfectly straight when you think you're pushing the joystick straight forward. So there we go. We've got axes A, B. B is left and right on this joystick. Camera's struggling to focus on that when I move them. But then you've got axis D is forwards and backwards on the right hand stick, and C is left and right on the right hand stick. So there you go. You can see how you can print some data to the screen, which is a really useful thing to be able to do. The last thing I want to show you is just some data from a sensor. It's going to be exactly the same. So I have here a gyro connected to my, so it's on a nice long cable so you can see it moving. I've got a gyro connected to port 3 of this brain. So what we're going to do is take the controller out, because we don't need that now, and we're going to add a gyro, which is in port 3 on my brain. So there we go, port 3. I'll leave the name, that's fine for now. And what I'm going to do is I'm just going to display the data from the gyro to the screen. So it's exactly the same principle. Let's just get this set up. So that's going to be sort of my basic framework of displaying the data. So on line 1, we're going to show something. On the line 2, we're going to show something else. The two things I want to show, well, actually, we've got three bits of data here we can show. So let's look at all three. We'll add a third one in as well in a minute. So we have gyro heading, gyro rotation, and gyro rate. And this is going to be useful because we want to see what the difference between those three things is. So what we can do is print them to the screen and actually look at the data coming back. So let's go to row 3, column 1. I'm going to, again, duplicate those blocks. I'm going to put heading in this one, rotation in this one, and rate in this one. And so here's my labels. Heading, rotation, and rate. And I'm going to print the data that's coming back at column 1, 2, 3, 4, 5, 6, 7, 8, 9 again, because then that will be after the word heading and leaving a space after the colon as well. Then we can snap that into there. So first part here is printing the labels, and our second part is printing the data on column 9. And then again at the end we're going to clear the display, but we'll have a little short 0.1 wait before we do, so that we get a chance to see the data. So the gyro has got a little symbol on the top. It's like a little Z with an arrow going around. That's the top. So I'm going to hold that facing up, and then we're going to rotate it around that axis and see what the data looks like. So let's download that and run it. So there we go. I've made a bit of a mistake there because the word rotation is longer than heading, and so you can actually see that the minus sign on rotation has overwritten the colon on there. So what I'm going to do is quickly go back into my code, change these all to 11, give it plenty of space, download it again and run it again. There we go, it's a bit clearer, we can see that. So these are our 3 bits of data. So what is heading, rotation, and rate? We can sort of see now what the difference is. Heading is an absolute value. So wherever it was switched on, straight ahead for the gyro would be 0. And as I go back towards 0 and rotate past it, I go back to 360 degrees. It's like a compass heading. And so that is an absolute value. And it's always the same whenever I point the gyro in a given direction. So if I point the gyro towards myself, it's 360 300-ish, and if I do a full circle and come back, it will still be the same value. Whereas rotation is cumulative. If you look, if I keep turning it and turning it, whilst heading goes back to 0 each time I go round, it adds 360 to rotation, so it's a cumulative value. And rate is just the rate of rotation in degrees per second, so how quickly it's rotating. So if I spin it really fast, that jumps up to a high value, and then it drops back down as I stop spinning. So that's rate. You can actually use the help built into VEXcode to get some really cool feedback from that. So if you just get the little question mark up here and then click on a block, so in this case we want to see what heading in degrees means, you'll get a nice little explanation about what heading is, what rotation is, and what rate in degrees per second is. And you can do that for any block. So any block that you click on will give you a nice little bit of information about how to use it and what the data means. The last thing I want to say about the display is you can always use multiple threads in a program. What I mean by multiple threads is, say you have this one to display data to the screen for the gyro, you can start a second thread. So let's go to events and add another when start. And you could use this one for other code, for your autonomous, for actually moving your robot. So you don't have to keep interrupting this print cycle. This will happen whilst whatever is attached to your second thread is happening. So this could be all my robot movements attached to this one, and I could just have one thread that purely concerns itself with displaying information to the screen. So don't think you need to put your robot movement commands in here, because of course they will interrupt how the screen is updating and how live and how accurate that data is. So that's the VEX IQ Brain screen. I think it's a really useful thing to be able to use, and hopefully that will help you to perfect your autonomous programs and get a little bit more accuracy from the sensors that you're using. Join us again in a couple of days when we will be doing another VEXcode IQ Blocks video. Thanks very much for watching.